I conduct research in dynamics, control systems, intelligent systems, and computational mechanics, and I've applied them to various areas including automotive engineering and transportation safety. We know statistically that drivers are 90% of probable cause of all crashes. Therefore, anything we can do to help them to drive more safely can save lives. In the area of drowsy and fatigued drivers, we came up with very effective signal processing methods to determine whether the drivers are drowsy or not. We use the vehicle's steering wheel sensor data and do some post-processing to evaluate and recognize anomalies in the driving behavior. Based on that, the algorithms make a decision whether the driver is drowsy or not and alert the driver when necessary. We also worked on automatic steering assist control systems for emergency maneuvers when braking alone is not sufficient to mitigate a potential crash. More recently, I've been exploring different methods for not only understanding the control actions of the driver, but also the thought and the mind of the driver. Our purpose is to monitor drivers' intentions preceding their actions. To do that, we're using EEG instrumentation to measure the driver's brain waves, and we're trying to understand what happens in the brain of the drivers as they're confronted with different situations or stimuli, or when they plan to take a specific control action. So the real focus of my research has been on advanced driver assistance systems for collision avoidance, which is also known as semi-autonomous driving. The major challenge in this area is the human variability for designing systems that include driver-vehicle interface. Earlier, I also worked on reducing fatalities and severities of injuries sustained in crashes through biomechanics and crashworthiness research. Some of my colleagues work in this area too. This includes crash testing and analysis, and optimal design of vehicle safety systems and roadside barriers. This human-centric safety focus of our work and our comprehensive research covering pre-collision to crash to post-crash mitigation is what makes our transportation safety research and academic program very unique at GW. My research is broad enough that includes many different areas of engineering, and throughout the years I have supervised students from almost all of our School of Engineering departments. The students I look for are very result-oriented. They're genuinely interested in problems we are studying, and they're willing to work very hard to accomplish their research tasks.